Hello learners, today we will discuss the some part of the quality control, that is the statistical quality control. This is a very important topic as per as the industry point of view. So statistical quality control. So it can be defined as it is the collection, analysis and interpretation of data to solve a particular problem. If in an industry, so the large data is there, the big size data is there, so number of parameters are there, then the SQC stands for the statistical quality control, and which is nothing but collection collection of the data from the various resources, analyze it and interpret that data to solve a particular problem or to check whether where is the problem that is occurred. It is a systematic approach to collection of data, analysis of data compiled to draw interference in order to install a suitable measure remedial measures and procedures. So in this SQC, it is nothing but the scientific approach of the collection of the data, analysis of data. When you compile the data, you have to analyze the data and to draw some inferences, which means to draw some conclusion from that particular the data, to get the some remedial measures and the procedures. So SQC techniques provide criteria to discriminate between random and non-random variability. It refers to statistical techniques employed for maintenance of uniform quality in a continuous flow of manufactured product through the statistical process. SQC may be defined as the management technique by means of which products of uniform acceptable quality are manufactured. So there must be a product which maintains the uniform acceptable quality and which can be accepted by the any supplier or any that particular vendor, and that is the management. SQC applies the theory of probability to sample testing or inspection. So in the SQC, it is mainly the theory of probability is responsible to sample the test or to get the inspection. So the basic principle of SQC is to prevent the production of defective parts. So SQC technique is basically used to prevent the production of defective parts, because in many cases the defective parts gets produced and which will be unnecessary increases the cost of that particular product. So reduce the defective parts by inspecting them and establishing control over the manufacturing process during the production, instead of waiting to inspect them after they have been completed when it is too late to take the corrective action. So in the SQC, the your component or the product get checked before the final the product get completed. Okay, so it will be establishing or inspecting them and establishing the control over the manufacturing process during the production, instead of waiting to inspect them after they have been completed when it is too late to take the corrective action. So before your manufactured product get dispatched or gets towards the quality control to check the final quality, before that your parts gets inspected. SQC procedures are based on well established statistical methods. They have been developed to provide economical means of maintaining the continual analysis. That means it is also used uh, because of the economical one, and it is used to control the processes and products. So what are the objectives? So first objective is nothing but to improve the relations of the customer and manufacturer. That means to get the quality product, so your customer also gets happy. So from that the relation gets maintained. Consistent quality, less scrap and rework. So by using the SQC methods, the your product gets inspected during the manufacturing process, so it maintains the continuous quality, and because of that so less scrap and rework is there. Effective and efficient utilization of available resources. Of course, if there is a no rework or no scrap, then there must be a effective and efficient utilization of available resources. Standard inspection methods, it uses the standard inspection methods. Easy detection of fault, it is very easy to detect the faults in a during the manufacturing process. Creating quality awareness among the employees. So by using this SQC, so it also creates the quality between the employees, so that the you must produce your the parts in a good quality. To bring the adjustment in a process in case of heavy rejection, if is there if in the industry if there is a heavy rejections are there, then there may be changes takes place in the processes. To take different measures to improve the standard of quality of products. So every time the your quality of the product gets checked, so that the every time the different measures are used. Next, what are the advantages? So it is a stable process which meets the product specification, provides the evidence that the process has conditions which is, if maintained, will result the acceptable product. An analysis for statistical control, which includes the plotting of the data in order of production, will identify trends over the time that are hidden by histograms. Knowing a process is in a statistical control provides a direction to those who are trying to make a long term reduction in a process variability. Knowing that a process is in statistical control, it is very useful to the worker running a process. A process having the special causes is unstable and excessive variation may hide the effect of changes being introduced to achieve some improvement. A process in statistical control operates with less variability than a process having the special causes. Lower variability has become an important tool of inspection. Because of the SQC, we have the less reduction in cost per piece and scrap, reduction in quality inspection and increase in quality consciousness among our various employees, saving in excess use of material and removing production bottlenecks, improvement in quality and greater customer satisfaction. So overall the advantages is nothing but to reduce the scrap, to get the good quality material, improvement in the quality control, the quality of the material. That's why there must be a the greater customer satisfaction, and because of that customer manufacturer relationship is. So there are various SQC techniques. So first one SQC technique is the SQC technique is divided into two. First by using the control charts. Okay, and second one is the product control. So SQC technique is for the process control, and this one is the product control. So in the product control, these are again used for the attribute. So C chart is there, P chart is there, and NP chart is there. So various control charts are there, and here, so for the variable charts, so in the process control, so variable is the X bar chart and R chart. So these are the different SQC techniques are used for the variable attribute data. So statistical data, so this is data are of two types, such as the variable data and attribute data. The variable data, when a record is made of an actual measured quality characteristics, such as a dimension expressed in microns in mm, the quality characteristics said to be variable. A variable can have all possible values between any two given limits or outside the limits. The variability may be occur due to assignable causes and unassignable causes also. So if you take the examples that the weight in kg, temperature in degree centigrade, hardness in Rockwell, dimensions of a part, measure distance between any two points, pedal axle diameter, etc. So those parameters, those characteristics we can measure actually, then we call it as a variable data. Attribute data, when a record is made as to the number of items conforming or not conforming to any specified requirement, it is said to be recorded by the attributes. It simply notes that presence or absence of quality characteristics. It refers to those parts which do not possess the characteristics of conformity. The examples of the attribute data are cracks found in a sheet after welding, surface finish of a component, surface finish of a painted surface. So first we'll discuss the frequency distribution. It is the number of items a particular value variable repeats itself in a given set of data. After collecting the data, one can able to draw some inferences which should be helpful in deciding the course of action. This data has to be presented in a more manageable form to be practical used. One such a widely used method is to present it as a frequency distribution. So here the number of employees are given and the frequency occurrence is given. Okay, so here the number of employee, this may be any data for the present or absentee. So number of employee, that total number of 8 employees are absent the 3 times in a month, let's suppose. So here 3 bar are there. Okay, so number of employees, 9 employees are absent in a 2 days of a month. In this way we can represent the data in the tabulation form. So representation of a frequency distribution, first one is the histogram. It is a graphic display of a frequency distribution of a sample data. It can serve as a quick check on a several points within the process to determine where the greatest amount of variation occurs. Process. It is represented as a frequency distribution. Values of varying characteristics are shown on the x-axis and frequency occurs on the y-axis. So here the diameter is given. So 3.5 occurs in the 2 times, 3.5 occurs in a 3 times, similarly 3.6 occurs in a 2 times. So this is the data which we can represent it on a one graph. We call it as a histogram. Frequency polygon, it is consisted of a series of straight lines instead of the straight lines. Series straight lines joining a small circle which are plotted as a at a cell midpoint with a height proportional to the frequency. So here 3 point occur at the two levels. So here is the point 1 number. Similarly, this is the point 2 and this is the point number 3 again. And also we can join it in a series of the lines. So this is the frequency polygon. It can be used if two or more distributions are plotted on the same axis. If the topmost point of histogram rectangles are joined, then we get the frequency polygon. So here the frequency polygon is there and we can compare it with the standard deviation and that chart. Next one is the bar chart. So bar chart, we can see that the straight bars are there which is at the mid point of the cell. So this is the mid point of the cell. So by the same example 3 is there and this is the number of times is the 2 times. Here number of times are the 3 times and here the number of times are 2 times for the 3.6 mm diameter. The heights of the bar are proportional to the frequency in a respective cell. The chart is generally used to emphasize the variation and unevenness in data. Further investigation can be done to determine why variation was occurring. So we'll see next what is the mean, median and mode. So mean is the average, it is the average or arithmetic mean of all the values of a sample, and so obtained by dividing the sum of the all values in a set of readings in a set. So it can be written as so x is equal to, so number of samples x1 plus x2 plus x3 up to xn, so number of readings divided by total number of readings. So algebraically we can comment it as a x bar is equal to summation of x divided by number of the readings. So let's see the example. So in this case, so these are the number of readings, that is the 3.4, 3.6, 3.5 plus 3.6 and 3.4 plus 3.5. These are the diameter of the knuckle joint. So here, so we can, how we can calculate? So mean, so these are the number of readings divided by the total number of set of readings, so which gives the 3.5 mm. Next one is the median. When a set of readings are arranged in order to their magnitude, it may be ascending or descending. The median is the central value which has an equal number of readings on the either side and are arranged in the order of their magnitude. The median is the central value which has an equal number of readings on their either sides. So in the earlier example, so these are the examples of the diameters. So here we arrange in ascending order, so 3.4. So in this case the central value is the 3.5. So if you see here, so these are the three values from the either side. So our median is the 3.5. Mode, the frequency most frequently, what is the mode? Mode is the number of most frequently occurring value in term as a mode. So it is the observed value corresponding to the high point of the graph. In an example, the joint 3.5 occurs three times. So if you see here 3.3.5 3.5, so it occurs three times. So in a set of readings, those values occurring on maximum times, we can call it as a